Another step two question, question one from 2009, also question three from the Miscellaneous Pure, the support book. We have this two equations, state the line symmetry for each curve. So basically, we're thinking about trying to replace things with other things and seeing if it's still true. So for example, if we replace x with minus x, then this becomes minus x to the 4, which is just x to the 4, and the statement is still true. So this shows that it's symmetrical around the y-axis. Now, the reason it's there is because what I've just said there is if you replace any x input, like 6, with some minus 6 instead, you're still definitely at the same place because you still just have the same equation. So therefore, symmetrical around the y-axis. Of course, I don't know whether this is actually on the curve because I don't know what u is, but it doesn't matter. Likewise, if you replace y with minus y, you get the same business, so it's reflective in the x-axis as well. But also, if you replace x with minus y or x with y, both of these things will work. If you replace x with y, and also these arrows go both ways, if you replace y with x as well, because when you do that, what I'm saying is 6, 3 is going to turn into 3, 6. And if that's still on your curve, which it is because the curve is just the same as it was before, then it's reflective in the y equals x line, which essentially, when you reflect in this line, all your x's become y's and all your y's become x's, but the formula is still satisfied, so it's all fine. And finally, like I was saying, x is minus y. So if you replace x with minus y and replace minus y with x, or y with minus x, you get this, which is still the same equation, and so it's reflective in the line y equals minus x for much the same reason as the previous one was. So those are the 4 lines of symmetry of that curve. And likewise for this one here, if you can't replace x with minus x because then you get a minus here, but you can just swap over the y and the x. So it must be reflective in the line y equals x. And you can also swap over x with minus y, because remember, you're also swapping minus y for x, or y for minus x. So therefore you get 2 negatives in there and it's reflective. And then line y equals minus x, which you should have already known, because this is just y equals v over x. So you know it's the one that goes dum and dum either side. So it's clearly reflective in both of the diagonals. So okay, that's all done. We've got the two distinct curves intersect at A, B, C, D. So well, what does this look like? Basically, it's a bit like a circle. It's not a circle. X squared plus y squared equals, u or k is a circle. If you raise the powers up and keep them even like this, then you end up with a more sort of squared version of a circle. So GeoGebra thinks this is exactly what this one looks like. If you go to like x is 100 plus y is 100, you get basically just a square. It's kind of cool. But anyway, it doesn't matter for our purposes because all we're doing is sketching. Of course, I've already said this is y equals v over x, so it's the one that goes dum dum. And so our 4 points are A, B, C, D, reading anti-clockwise as it tells us to do. Now, A, as they've told us, is alpha, beta. They haven't told us the coordinates of B, C, or D, but we can work them out based on the symmetry that we just discussed. If this circle, and indeed the red curve, is symmetrical in that line, that means this point must transfer over to this point here exactly, and this is where the two things swap over to make BA, or beta alpha, I should say. And likewise, down here and down here, we can do the same sort of business, right? Reflective in the line y equals minus x, so these two swap over, but you also end up with a minus. It's pretty logical. Where it is, these are both negatives because it's in the 4th quadrant. And likewise down here will be minus beta, minus alpha. And those will be your 4 points. And yeah, that's actually that bit of the question done as well. Cool, all by symmetry. This triangle is going to be super helpful for us for the next bit. It's a really cheap little way of doing this next question. It's asking us to show that ABCD is a rectangle. 2 conditions for a rectangle. 1 is that you have 2 pairs of equal sides, and 2 is that you have right angles everywhere. So okay, let's just draw it. It goes across, well, okay, draw the first side of it. It goes across like this. Clearly this length is alpha minus beta. And also clearly this length is also alpha, this height minus this height beta. But of course, if they're both alpha minus beta, that means that the length of the hypotenuse, based on a scaled up version of this triangle here, is just going to be root 2 times alpha minus beta. I don't know why I wrote alpha plus beta there. That's just I think I just copy pasted something in the wrong place. Anyway, this is root 2 alpha plus beta, alpha minus beta. It just saves you doing some Pythagoras, just knowing the 1, 1 root 2 triangle. Very helpful. Likewise, this one we can also test, and we can also do these ones as well. This one is clearly just going to be, well, I said it was, I guess, x coordinates minus beta minus alpha. It doesn't really matter how you set this up. It's all fine. This turns out to be minus beta plus alpha, which of course is alpha minus beta. So this length, therefore, is root 2 alpha minus beta. So, okay, those lengths match. So that's all perfect. Let's do the bottom length as well. That goes across alpha minus beta. and it goes down beta minus minus alpha, or minus alpha minus beta. It's up to you. Doesn't really matter. Either case, you're going to get alpha plus beta both times, because two negatives, obviously, which makes this root 2 alpha plus beta. And likewise, the last one to test is this one up here, which will also work. You could probably just argue that it works by symmetry and only test 2 of these things, but in any case, definitely 2 pairs of equal sides. So now what about the angle? Well, we just need to do some gradient rise over run stuff. So for this line here, which I think is AB, the gradient is, so the rise is alpha minus beta, and the run is beta minus alpha. Of course, this is just -1, is it not? Because if you times the top by -1, you could just get the bottom. So that's just -1. And here, likewise, you can do the same kind of thing. You can say the gradient is beta minus minus alpha, which is beta plus alpha, over alpha minus minus beta, which is alpha plus beta, and that is just 1. And of course, because these two things are the negative reciprocal of each other, or because they times together to make -1, it doesn't really matter what we say. This must be 90. You could test all of the other 4, or you could just argue by symmetry that it works. I think I stopped bothering doing all of them. You could have probably done this for the lengths as well, to be honest, but just by symmetry, the rest of it's just going to work. Okay, last part of the question then. We've shown it's a rectangle. Find its area in terms of u and v. So its area is just length times width, right? So it's just this times this. The root 2's come together to make it 2, and this is a difference of squared, so it's beta squared minus alpha squared. Now we have to write that in terms of u and v. These are the equations of the curves. Alpha beta is on both, so therefore we can just put alpha beta into both of those. And what we're going to have to try and do here is force these two results into here. So what I think I'll do is I just square both sides, because that will get me beta to the 4s and alpha to the 4s. In fact, it will be even better than that. It will get me a beta to the 4 and a plus alpha to the 4. So beta to the 4 plus alpha to the 4 can just be replaced with u. And now what about this guy here? Well, he's the same as 2 alpha beta all squared. And alpha beta is just v, so we'll put that in as well. And now we can square root both sides, and the 4 can square root out, I guess, and we'll just be left with this, which I presume is probably how they want it. And now they've said to verify for the case u is 81, v is 4. So let's just put in u is 81 and v is 4. Just write it again, I guess, bigger. Yeah, root 4 is 2, mate. Come on. Anyway, 81 take away, what's this, 1632 is, what, 49? And of course, root 49 is 7, so 2 times 7 is 14, and we'll have the final answer done and dusted. Thank you for watching, and I'll see you next time.